Alrighty guys, we're on 6.4, inverse variation. So our objective for today is that students will be able to find inverse variation. So this lesson we're going to explore the type of rational relationship which is known as inverse variation. As it implies, when two variables varies inversely, all it means is that as one variable increases, the other decreases. So let's look at exercise 1. When two people are sitting on a seesaw, in order to balance themselves, we must adjust the distance and the weight. So for example, the weight times the distance of one person should be equal to the weight times the distance of another. So this will be our formula we're working with today. So in this formula, W1 and W2 are the weight, and then D1 and D2 are the distance. So let's see how this works. It says A. How far from the fulcrum, which is your balancing point, must a man who weighs 160 pounds sits if his 50-pound son is 16 feet from the fulcrum? So just use our formula. So we know this guy is 160 pounds and we want to know how far must he sit. So we don't know the distance. So keep it as D1. And his son is 50 pounds and he is 16 feet away. So all I'm going to do is I'm going to solve for my distance. I'm just going to simplify. This is 160D is equal to 800. Divide both sides by 160 and we get that the distance is equal to 5 feet. So notice I set these equal to each other. Now what if the boy was 80 pounds cousin now sits on the seesaw? How far must the cousin sit from the fulcrum if the boy has not changed his position? So this boy we know is where? From the first example, he was at 50 pounds and he was 16 feet from it. So we're going to set up our equation. So his cousin is 80 pounds. We don't know what the distance is. And the boy again is 50 pounds and 16 feet away. This becomes 80 is equal to 800. So the boy needs to be 10 feet away. Now looking at this, very important, it says when two variables vary inversely, their product always remains the same. And that's exactly why we set them equal to each other through the problem. So let's take a look at exercise 2. It says for each of the following, x and y varies inversely. Determine the missing value. First example says x equals 2, y equals 9, and I want to find a value when x is 6, what is y? So let's just set it up. I know 2 times 9 is going to be 6 times y. Simplify this. 18 is equal to 6. Divide both sides by 6. Y has to be equal to 3 in order for this to be true. Try the other one. 3 times 12 has to be equal to x times 6. 12 times 3 is 36 is equal to 6x. Divide both sides by 6. X should be equal to 6. Remember, our key objectives is that we need to make sure that their products are equal to each other. Now the last one, let's get here. 8 times 10 has to give you 2 times whatever y is. This becomes 80 is equal to 2y. Divide both sides by 2. 40 is equal to y. So for this exercise, all I want to do was to find numbers when I plug it into these question bar that will make the product of each equal to each other. Exercise 3 says if two variables w and z vary inversely, then which of the following must be true? So remember, right back up here, it says if two variables vary inversely, their product has to remain the same. So we need to look at which choice, 1, 2, 3, or 4, would make the product remains the same. So let's go through these step by step. The first choice said W increases by 3, Z decreases by 3. Now think of if I had minus 3 on this side and I add 3 on one side, would the product remains the same? No. So that's out. If both of them are increased by 3, my product will definitely not be the same. If W is multiplied by 3 and Z is divided by 3, then definitely my product is going to be the same. Alrighty, so let's move it along. Now, how do we apply these that we've been talking about? So exercise 4 says the force needed to pry a nail from a piece of wood varies inversely with the length of the crowbar used to remove the nail. If a 6-inch long crowbar requires 15 pounds of force, how many pounds will be required by an 18-inch long crowbar? So you have to remember our formula. It can be xy has to equal to y2 x2. This is the same thing as w1 d1 in our previous example. So this is 2. Oopsie. This should be d2. So it says the crowbar is 15 pounds times 6 inches long. How much pounds is required for an 18-inch? So 18, and we don't know what pounds, so we can call it P. Let's simplify that. This is 90 is equal to 18P. Divide both sides by 18. I get 5 pounds equal to P. So this is saying that for this crowbar, 18-inch long crowbar, we need a pound, 5 pounds is required to do the same exact thing. And again, remember, you have to remember the formula. Remember in the previous page, we said that the products, when two things are variables are very inversely, their product remains constant, meaning it does not change, it's the same. Moving to exercise 5. So the amount of time that it takes Carla to drive home from work each day varies inversely with the speed she is driving. It takes her 45 minutes to drive home in rush hour traffic when she is moving at 15 miles per hour. How much time does she save if she can drive traffic-free at 50 miles an hour? So first we need to find out, well, actually we know that it takes her 45 minutes at 15 miles an hour. We want to make this equal to how many minutes, so we could call it M, when she goes 50 miles an hour. So if we were to go ahead and multiply this and simplify, we get 675 is equal to 50M. Divide both sides by 50, and we will get 13.5 is equal to M. This 13.5 minutes is what it takes her to drive home. So this is minutes to drive home at 50 miles per hour. Now, but be careful, this question asks us for how much time does she save. So remember, she normally would take a 45 minutes, but now she's only using 13.5 minutes. So when I subtract this, I get 31.5 minutes, which is what she is saving if she travel traffic free at 50 miles an hour. Exercise 6, our last problem for today. So we're talking about a graph x, y equals k. I don't know what x, y, and k is, but let's look at 6. Consider equation xy equals 8. Rewrite this equation in the form y equals blank. So I want to get rid of x. So in this case, it's multiplying. What I need to do is divide both sides by x, and I'm left with y is equal to 8 over x. Using a table of values on your calculator, sketch the graph on the grid. Why is there an error in the table at x equals 0? So we need to get our calculators. Pause the video, grab your calculator. Alrighty, now that you got your calculator, we want to go to graph. And I want to enter our function, control division, 8 on the top, and x at the bottom. Hit enter, that's what you should see. So now this is what you are going to sketch on this graph right here. Now the question for the last part of it, it says, if we go to table, menu, table, split screen, at x equals 0, it says hashtag undefined. Why is there an error there? Now, look at the function. This is my function. What happens when I replace x with 0? So why is there an error? Because we cannot divide by 0. Because we cannot divide by 0. Remember, anytime you divide by 0, it becomes undefined. That's impossible for us to do. Alrighty, that's the end of our lesson. Go ahead, practice those problems, and come see me for your mastery quiz.